This video goes over how to find the measures of central tendency of a data set. The first one we're going to look at is the mean. This is sometimes known as the average, and it is found by dividing the sum of all the data by the number of pieces of data. So mathematically, we represent this as x bar is equal to sigma x divided by n. This funky looking E is a sigma, and it just means sum of, and this symbol here is just read as x bar. The next measure that we're going to look at is the median. This is the middle value in an ordered set of data. And then the last one is the mode, and this is the value that occurs most frequently. The other piece that you need to know when analyzing a set of data is an outlier. And so an outlier is a point or points in a set of data that are significantly far from the majority of the points. Majority. In a little while, we will get into a mathematical way to calculate the outliers, but for right now, we're just going to use our judgment and in determining what is significantly far from the majority of points. The outliers have the greatest effect on the mean, which we'll see in our next example. Okay, so here we've got Sammy's math marks, and we're going to find those three measures of central tendency. So mean, median, and mode. To find our mean, we're going to add up all of Sammy's math scores. So doing that is going to give us 717, and then we're going to divide by the number of math marks, which is 10. So this is our sum of math marks. And this is our number of math marks. And so our mean is 71.7. The next measure that we're going to find is our median. So in order to find that, the first thing we have to do is arrange our data points. So I'm going to start with 29. Next is 68, 70, 71, 72, 76, 77, two 82s, and then a 90. And now I'm going to look for my middle. Since I have an even number, I've got two middle numbers, which means that my median, which we can represent with a capital M, is found by adding those two numbers together and dividing by 2, which gives us a median value of 74. The last measure that we're going to calculate is our mode. That's the value that occurs most often, which in this case is 82, which occurs twice. Now, what we want to do is I want to show you the impact of an outlier. So you might have noticed that this score right here is significantly different than the rest of the scores. So let's remove the outlier and then recalculate. Okay, so let me underline outlier in red, and the outlier, the one that we're going to remove, is that 29. So recalculating the mean, my new total is going to be the sum of the math marks, take away 29. So that would give me 688. and now I only have 9 math scores that I'm considering. Evaluating that on my calculator gives me a mean of 76.4, which is quite a bit different. That's about 5% than my original mean that I calculated. B, we're going to do our median, so our capital M. In order to do that, I'm going to look back up here. What do I want to do? Let's rewrite our data set here, just above. So 68, 70, 71, 72, 76, 77, 282s, and then a 90. So now I have an odd number. So I actually do have a middle number, 1, 2, 3, 4, 5, this one right here. I've got 4 pieces of data on either side. So that means my median is 76, not that different than my original median that I calculated. The last one is the mode, still 82, because that is the value that occurs most. So what you can see is that this one, the mean, has the biggest change when we take out that outlier. Now that we've looked at a basic set of data, we're going to extend our idea of calculating the mean a little bit, and we're going to look at calculating the weighted mean. So sometimes certain data are more significant than others. So significant. Okay, for example, it's not as true anymore. Okay, but for example, exams would be more important than a test. Okay, and doing better on an assessment, so a test would be more important than a quiz. In some cases, this is more true sort of in traditional education. It's a little bit less true now. There's more flexibility, but it gives you an idea of what weighted mean actually means. Okay. And so a weighted mean is going to reflect the importance of that data. And mathematically, we represent it like this. So still x bar, just like we did before. And then we've got the sum of w times x, so our weight factor times the x value over the sum of all of our weightings, okay? So let's do 2 examples for calculating the weighted mean. So here is an example. We've got the tests are 45%, quizzes are 15, assignments 10, exam 30. And then we've got our corresponding marks down here. And what I'm asking you to do is calculate the mark, so using this weighted mean formula. So our mark is going to be the sum of our weights times our test values over the sum of our weightings. So the first one is my test, so that's worth 45% times my mark, 65, plus my weighting for quizzes times the mark on the quiz, plus the weighting for the assignments times the assignment, plus the weighting for the exam, and then times the mark I got on the exam, and then I'm going to divide by the sum of my weights. So 45%, 15%, 10%, and 30%. Evaluating that and figuring out the answer is going to give me 68.45, which we can round as a percent to 68.5 would be the weighted average. Another example where you can use a weighted average is where you have a frequency table. So let's fill in the survey data. So if we've got, these are the number of slices students ate of pizza in a week, and we're going to calculate the weighted mean. So what we want to know is how many slices on average students ate per week. So let's fill in this survey data. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is just data I'm giving to you on a test or a quiz or an assignment, you would have this table written in. So 1, 2, 3, 4, 5, 6, 7. And then the frequency, 7, 5, 15, 12, 8, 4, 5, and 2. And then what we're going to look at is calculating our weighted mean. So in this case, our frequency represents our weighting here. So for my first one, I've got 7 times 0 people. Okay, 0 slices. Then I'm going to do the same thing. So 5 people had 1 slice. 15 people had 2 slices. 12 people had 3 slices. 8 people had 4 slices. 4 people had 5 slices. 5 people had 6 slices. And then 2 people had 7 slices. So adding all those up, and then I'm going to divide by the sum of my weights, or the sum of my frequencies. So 7 plus 5 plus 15 plus 12 plus 8 plus 4 plus 5 plus 2. Evaluating that, so we've got 167 on top divided by 58 on the bottom, which is going to give us approximately 2.9 slices per week. And those are a few examples of how to calculate mean, median, and mode, and then how to calculate the weighted mean of a data set.